Alright, for this lesson we're going to learn about dilations and expansions and contractions. So first off, a dilation can be an expansion, which is to enlarge something, but it could also be a contraction, which is to shrink. An expansion has a scale that's greater than 1, and a contraction has a scale that's less than 1. So let's talk about applying this to coordinates. First off, you're going to use the scale, which is just the multiplier used to create the dilation, and then you use the distributive property to multiply that scale, meaning you multiply each coordinate. So let's take a look at an example. If I wanted to enlarge the point -1, 4 by a factor of 5, first thing I need to do is multiply by 5. So that means I need to multiply each coordinate by 5. So the x value by 5 and the y value by 5. So -1 times 5 gives me -5, and 4 times 5 gives me 20. So my enlarged point is -5, 20. Alright, now to expand or contract a figure on a coordinate plane. So what we're going to do is use the vertices, which are the corners of polygons, and then we're going to multiply by the scale value and plot our new coordinates. So let's take a look at an example. So let's create a triangle 1/3 the size of its original value. So first thing, I need to find the vertices. So a triangle has 3 corners, so I have the top, the bottom one, and then the right one. I need to know the coordinates of each of those. So now I need to put the coordinates in there. So now I have the coordinates of all 3 points of my original triangle. 0, 6, 0, 3, and 6, 3. So I take a look at my scale factor. It says create a triangle 1/3 the size. So that means to multiply each of those points by 1/3. So I have 1/3 times 0, 1/3 times 6, which will give me 0, 2. And then I'll need to do the same thing for the next point. I distribute that 1/3 to the 0 and that 1/3 to the 3. 1/3 times 0 is 0, and 1/3 times 3 is 1. So now my new point from 0, 3 becomes 0, 1. And again, the same thing for the last point. I distribute the 1/3 to the 6 and the 1/3 to the 3 and get the point 2, 1. So now I have my 3 new vertices, 0, 2, 0, 1, and 2, 1. So all I need to do now is plot them on the coordinate. So 0, 2, 0, 1, and then 2, 1. And then if I'd like, I can connect the dots to make the similar triangle. Another thing we can do with dilations is determine a scale given some pictures. So what we do is we measure the length of an original side, measure the length of a new figure, and then create a ratio, which is just a fraction, of the new divided by the original. So let's take a look at this example. I want to find the size change from A to B. Well, A is the larger blue box and green is the smaller box. So I take a look at my endpoints. I'm at 8 and -8, which gives me a length of 16. So the original has a length of 16. My new shape, the green box, has points at 4 and -4, which gives me a distance of 8. So now that I have the original length and the new length, I can create that ratio. So again, my original length was 16 and my new length is 8. So I take my new length and divide that by my original length, which gives me 8/16, which can be reduced to 1/2, because 8 goes into 8 once, and 8 goes into 16 twice. So that gives me my final answer that the size change is 1/2. And now we can plot points, expand or contract figures, and find a scale.